Hey, this is Passy from Passy's World of ICT, the guy with the white hat. And today in our VBNet Fun and Games course that we're doing, we've got Tic Tac Toe if you're American, or Naughts and Crosses if you're English, and 3 in a row, whatever you like to call it. It's a fun game, and it's even more fun to make in VBNet, and that's exactly what we're going to do today. So let's get into it. All right, so in this lesson, we'll first off build a traditional tic-tac-toe noughts and crosses. So we'll show you that one. Let's see where we are here. No, we've got to get to where we can find it. Here it is. I think it's this one. All right. I'm not going too well here today. Yeah, there we go. All right, so this is traditional noughts and crosses tic-tac-toe. So I have one player that's X and one player that's O. So player 2 has been randomly selected to go first. So their best strategy is to go into that middle square right there. Player 1's not so smart, and they're going to go here. And then player 1, 2, the O's go here. Oops, better block them off and stop them from winning. Uh-oh, O's have 2 ways of winning. They've done it. So, well, we'll just go here. And there we are. We've got a winner, and player 2 is the winner. And we've got an animated GIF congratulating us. So that is really cool. So anyway, that's kind of the basic one. Right, so that's that one done. Then you can also substitute your own pictures instead of having X's and O's, and this is kind of fun too. So player 2, Mr. Green Koala, he's going first. So he's picking the middle square. But Passy's smart. He's going to go on one of those diagonals. Green Koala's going to go here. Passy blocks him off. Green Koala goes there. Oh no, he's beaten Passy, but no, Passy is going to win. Silly Koala, and I'm the winner. All right, so that's a fun one too, just to have your own pictures. And look, you don't have to do Passy and Koala, although these ones are available in the downloads. If you want to, you can do a different one like Batman, and the Riddler would be a good one to do. So Riddler is going first here. Batman, better block him off from winning. Batman, block him off, up, and nope, that's a no-winner game. That's equal, okay? So, yeah, you can have all sorts of things to do this. You don't have to actually do the ones we've done. We have to click that OK message before we can close that, by the way. Let's just get back into where we're up to. All right, so these download images are available in the lesson downloads. You can check that out in the video link. And you can have Passy versus the Australian cute and cuddly koala bear with really sharp claws, actually. So you've got to be careful of those guys. So maybe you want to do Batman, Riddler. You could do sports teams logos. Have your 2 favorite sports teams versing each other. Singers, movie actors, rappers. Maybe like the Mustang versus the Chevy Camaro, Ken and Barbie, whatever, anime characters, whatever your thing is, you can do it that way, all right? But anyway, look, that's just a simple matter of substituting which images are in the player 1 and 2 image boxes. All the rest of the coding is exactly the same as we're going to show you for the traditional game. So for the traditional game, which we're going to build first, this classic X's and O's game, we're going to learn a lot of stuff doing this, all right? So we'll have to work out the algorithm for the game so we can design it and figure out how to do code. But before you do code, you always write your pseudocode first, which is kind of like your plain English version to make things easier. So we'll do that. Then we'll divide the game into subroutines because it's going to be a fairly big game, all right? So it'll need to be divided up to work out randomly which player goes first or second, because whoever goes first has an advantage because they claim that middle square, and that gives them more options and more ways of winning. So we need to alternate that. Once a player is gone too, you need to swap to the other player, then they have their turn, swap to the other player. So we need to keep this alternating swapping between players going during the games. And how do you know that a square's already taken? Like for us, we've got our eyes and we can see, but the computer's really dumb, it can't see anything. So we actually have to tag the picture boxes so that we know they're already filled up and someone else can't click over the top of them and change the symbol that's in there. We also need to be continually checking for a winner. So we're going to get the computer to work out when the winner happens, just so we can do some more algorithmics and programming and learn a lot more stuff. And those winning sort of celebration GIFs that we've got, we'll show you how to put those into picture boxes. And so progressively, we're going to develop a program here that's probably going to have over 500 lines of code. And when you do the challenge tasks, I think it comes up to 700 lines of code. Now, don't panic. You're thinking, oh, I'll never be able to write that many words of code. I'm just a beginner. Look, it's fine. It's like when if someone had to do a travel brochure on Africa, let's say, They're not just going to sit down at their computer, start typing, and 2 hours later, whoa, the whole thing's finished, all right? It doesn't work like that. They'd have to plan it out. Maybe they're doing 3 or 5 countries, so they're going to have something about South Africa, something about Kenya, Namibia, Tanzania, and Kenya. All right, so that will break it into sections, and they'll work on one section at a time. It might even take them a whole week to write the article, research it, edit it, all right? That people don't sit down there and do things in one go. So we're going to break it up into sections, and you can use the YouTube timeline index to stop at any time in this lesson and then come back to it at exactly the same spot using the timeline index. Also, what we suggest is, because we're a bit of a slow talker, you increase the video speed using that player's cog on the player bar, just to play it at 1.5x or even 1.75x, because we tend to talk too much and go too slowly like we're doing right now. So the form design is a little bit involved, because we're going to get that sort of crisscross grid happening with some other things. So we've got our ICO image here. So we've got one of us actually, Passy, a little ICO image you can download and put that in the corner. Or you can make your own ICO image. If you go back to our lesson, it was one of the clock lessons that teaches you how to do that and how you can use an online ICO converter. Then the Form 1, name of it, we always are just leaving as Form 1 for our projects. This back color, which is sort of a light gray, is called white smoke. So you need to find that in the web colors. And the size of ours, just if you're wondering how big you'll need to make it, it's around 1200 by 700, okay, for the size. And we need a label put up here with a 4 color of red. And I think that font size is 26 or something in the 20s anyway. So that goes there for our big heading up the top, just a plain old label. Now, to make this crisscross shape, you use panels. And so that they are all the same width and length and look good, and the squares are all going to fit in them equally, we suggest you make them 30 wide and 512 long, and the color we've used is gold. So you can make this first one, and then you can actually Control-C, Control-V and paste for that one. But you can't rotate things like you can in sort of Word and PowerPoint. So you'll then have to make one of the horizontal ones. Make sure it's the same size, 30 and 512, so you get a perfectly equal grid. This label here that says player turn isn't so important, but this one that's got the player in it whose current turn it is, that's really important for the program, so you can swap between the players and things. So that must be named LBL turn. And yeah, these font sizes we're using here are 26-point fonts. Okay, you'll need a picture box for player one's image. So if you're doing Passy versus the Koala, you'll put the Passy image in there that you've downloaded, or you can get our fabulous 3D Red X, which we made in Adobe Fireworks, a good product which not a lot of people use these days, and that needs to have a specific size, 135 by 116. And we set that up and put our player 1 image in there. And underneath we'll need the player 2 images, and you can get that O image, which again we made in Adobe Fireworks, from the downloads file for this lesson. You need a picture box where that animated sort of party celebration GIF is going to go into, and you'll need another picture box here, and that needs to be called Pick P2 Winner for the other animated GIF. So these need to be Pick P1 Winner and Pick P2 Winner. So all these names here, make sure you get them exactly the same on your form as they are here in the design specification. Otherwise the program code's not going to pick up the right parts of the form and do the right things. A button there called BTN End, where we can just end the program if we want to. And the picture boxes, we need 9 of them, and they're all 153 by 143 in their size. Now, the way you lay them out on the grid is super important for what we're going to do in the program when we get the program to check whether we've got a winner yet, okay? So it's really important to follow this pattern of grid layout. So we're basically going left to right. So this guy up here in the top left-hand corner is pick 1, pick 2, pick 3, pick 4. The very middle one is pick 5, pick 6, pick 7, pick 8, and pick 9. So PIC with little letters. I've got some big letters there. I thought I'd fix that up. Okay, they all need to be little letters. Pick 1, pick 2, pick 3. So I'll have to make sure that is fixed up in the download instructions. For the winner, yeah, LBL P1 winner here, we'll need that. And that's just in Arial rounded font with medium blue background, just to make it stand out a little bit better. And you'll need an LBL P2 winner as well to announce if player 2 has won the game. And I'm pretty sure that's everything for the form design. So you might want to pause the video at this stage and create that form design. And then you can come back and look at how we're going to work out how we're going to build a program behind here and how we're going to design it. Yeah, X and O images as well as the Koala and Blue Passy images are in the downloads. And in the instructions and downloads, we'll show you where you can get those GIFs and exactly how they work and how to put them in the program. So it's well worth getting the downloads for this lesson. Now, this game works by the players being different characters, X versus O, and they have to swap, take one turn at a time until they've filled up all those empty 9 squares on the playing grid. All right, now the game's won whenever a player gets 3 in a row. So it could be 3 going across on any of those 3 rows. It could be 3 going vertically down on any of the 3 columns, or they could even go diagonally across left to right or from right to left. So altogether that gives us 3, 6, or 2 of those. Anyway, we'll show you in a minute. How many there are. I think there's 8 combinations. Although we've got 9 squares, there's 8 ways for one player to win. So if all 9 squares, though, if they fill up and there is no winner, that can happen as well. So we also need to remember that when we're designing our game, because here we've got a game where no one managed to get 3 in a row, but they took alternating turns and filled up the whole grid. So if that happens, we're just going to pop up a little message box here that says game over, no winner. All right, so we need to remember that that's the last thing we check for. Hey, are all 9 squares filled up already and nobody's won? Oh, okay, well, it must be a draw. Because remember, the computer has no eyes and can't see what's going on, so it's all going to have to be done with design and program code. So what do we need this program to do? Well, it's going to need to randomly choose which player has the first turn to go, and then swap between the 2 players turn by turn as they fill in the squares, and make sure it stops when all 9 squares are filled in and doesn't keep going. We'll need to claim squares, so a player clicks on a square and then their particular X or O symbol goes in, but then that square needs to be tagged, marked as claimed, so that if someone else clicks on it later on, they can't put their symbol over the top of it because someone else has already done it. See, with pen and paper and human eyes and a brain, it's so much easier to do, but the computer's blind and needs everything step by step. So that's kind of where this gets challenging and makes it real interesting. This is an insight into, you'll be surprised how much code you have to put just to make a simple game. And we'll break this down into a number of events and subroutines. Okay, so we'll build it up step by step, testing. So you just build a little bit and then you test it, make sure that's working. Then you think, okay, what's the next little bit I need to add on? You add that on and test. So all this little adding on and testing, that's called the agile development method, okay? So in all of our lessons, we're always using the agile development method is what it's called. All right, so to win the game, there are 8 ways for each player to win the game. All right, they can get all 3 squares across the top, they can get the 3 squares in the middle, or the 3 squares along the bottom in a line or in a row. Okay, so horizontally going across, there's 3 ways. Vertically going down, there are also 3 ways. You get all of these left-hand ones, you get all of the middle ones, or you get all of the right ones. Then, apart from those 6 things we've just done, there's also 2 more. 2 more, which are the diagonals. You can get pick 1, pick 5, pick 9, or you can get pick 7, pick 5, pick 3, going in a diagonal downhill shape. All right, so we can visually map this out with this grid. So that's one way of winning for one player, getting across in the middle, getting across in the bottom, getting down in the left, down in the middle, down in the right, or getting a diagonal 3 in a row. So that's 8 combinations, but you've got to remember we've got 2 players. So altogether there are 8 times 2 is 16 checks the computer's going to have to do for winning. Plus it'll also have to do that check as to whether maybe all the squares are filled up and 9 squares are done and we don't have a winner and it's a draw, okay? So that's kind of, you've got to have that in your head about this is how the game works. I've got 8 checks to do for each player. Plus I've got to remember there's that check for if all the squares are filled up. So I better be counting how many squares are filled up as the program goes so that I continually check. And if someone's just clicked and that's square number 9, we know if there weren't any winners, well, it's time to call it a draw and stop the program, okay? So kind of have that all in your head while we're getting into this code, because we'll get deep into the code and you might get lost, but you can always come back to this design and figure out where we're up to. So then next thing to do is to do pseudocode for this gameplay. So we understand in our head now what the gameplay is. We need to randomly pick someone to go first, and we need to keep a count of squares in case all 9 have filled up. We need to, each time a square's click, check, hey, has somebody won the game yet? And it's time to stop. Okay, so how it's going to work is we'll display the initial screen. We need some variables because we'll need a counter variable to keep count of how many squares are filled in at the moment. The winner and messages and animated GIFs, we want them to go invisible. So they'll be on the form at the start when we design it in designer view, but we'll make them invisible, make visible equals false property for them so that they can't be seen. And when someone does win, that's when we'll change them back to visible and we'll be able to see them. Okay, so every time we repeat doing all of this here until either a player's won or the game is over because all 9 squares are filled and it's a draw, or somebody clicks on that end button just to finish the game up. So if any picture box is being clicked, if it's player 1's turn, we place their image into that particular picture box and we tag that picture box now as claimed by player 1 so that player 2 can't come along later and click on top of it and replace the image. Okay, and then we'll need to check, is it end of game yet? All right, otherwise, on any particular turn of the game, if it's player 2's turn, we got to put their O image into the picture box and tag that picture box now. That belongs to player 2, so no one else can click it again a second time, and check for end of game, which is going to be a separate subroutine we'll show you in a minute. And then down here, if the end button, which is also you could call a quit button, if that's been pressed, we're just going to end the program. And that's sort of the end if of that processing that's going to repeat over and over and over until the game ends, okay? And when we check for winner, check for end of game, well, we're checking for all of these 8 conditions here for each player. So how that subroutine is going to work is we check for all 8 of these winning combinations for player 1, and then we got to check it again for player 2. All right, so we got to do it for player 1 and do it for player 2, all 8 combinations. Then we also have to look at our squares counter, and if that's up to 9 already, we know the game's over. So if nobody's won and 9 squares are full, we need to call it a draw and stop the game. All right, so that's kind of our whole top-end, high-end design in pseudocode. And you need to come back and refer to this if you get lost, all right? So that's kind of the big Google Maps overhead image, and we're going to be zooming into Street View and doing some detailed work. But if you get lost, come back to this one and try and work out where in the Street View we're up to on this grid, or something like that anyway. All right, so the first thing we need to do is put some code into the form load subroutine, which we've done in different programs, and that's going to set up a few initial things for us, all right? So you just double click anywhere in that kind of blank form background, and then you type some code in. So when you click in the blank form background, it'll do this form 1 load subroutine. So it'll write the sub and the end sub. You should remember that from previous lessons. Above that, between public class form 1 and where that's starting, we're just going to put this comment in what our game is, a title, and we need to have something to count the squares with, an integer number we can use to count how many squares are filled in. We'll also need a random number. We're going to use that when we work out who's going first and who's going second at the start of the game. And we also need to have something to keep track of that the game's over. So if someone wins, it's game over. If all 9 squares are filled, it's game over. So we also need this thing called a flag or a tracker, a Boolean variable, BLN, which can be true or false. And we're going to set it up as false at the moment because the game is not over, because we're just starting the game and doing the initialization. So that's why we're setting up those things there. That's setting up the variables for the program. And then down in here is where we're going to set up, when it loads, we want the winner message to be invisible. So any of those things that say winner in the blue box, we want to turn them off so you can't see them on the form. And we want the animated GIF too as well, the little party thing for that particular winning person. We want that turned off so you can't see it as well. So we set that to false, and that'll get everything set up for the start of the program. And because we've just done something, some work using this agile development cycle, we will now straight away test it. So use the green arrow to run the program after you've typed that code in. And what you'll find is this was our form design screen originally, where you put everything on there, including the winner message for each player and also their particular animated celebration GIF. Okay, so you put those things on here, but when it runs, because we're just starting, we don't want to see those things. So notice over on this, when the screen is running, because we did that stuff in the form load processing, we don't see any of those, okay? So that's all good, and that's one little step ticked off on our pseudocode right up the top there, where we're going to initialize variables and set the pictures and everything to invisible. So on to the next thing. How do we claim picture boxes on the grid? All right, so I'll just look at this first top left-hand picture box first, pick one, and look at, okay, if player one picks it, we need to tag it as belonging to player one, claim it for player one. But if it's player two's turn and they happen to click this pick one box in the top left-hand corner, we need to set the tag to 2 so that we know it belongs to player 2. And that's gonna help us, one, to make sure another player doesn't click over the top and put an X there. And it's also going to help us in checking for whether we have a winner yet or not. Okay, so we're just looking at this top left-hand box here, which you should have named as pick one. So this is how they should be named. Remember, this is critically important that this is, you use little letters, and that's pick one, pick two, pick three, pick four, pick five right in the middle, pick six, pick seven, pick eight, pick nine. So they've got to be in this pattern for their names on the form in their properties. So you got to make sure that's right. So if we double click on this particular picture box we want, that'll give us the event for when someone clicks it. So double click on the picture box and VBNet will write this private sub that if pick one's been clicked, we're going to do all this stuff in here, and it'll write the end sub part, and we have to do all this in between stuff. Now what's the in between stuff doing? Well, first we check if pick one tag equals a pair of quotes, which means nothing. So that will mean that the box is sitting there as we see it on the left now with nothing in it, okay? Well then, if it's player one's turn, we want to put their image into that picture box. So pick player one image is this guy here, the red X that's next to player one. So that's an empty picture box over there in the top left-hand corner. But this code here, pick one image, we're going to make the image of that empty picture box equal pick player one's image. So that'll get an X put in that box. Now, player one has claimed that box by putting an X in it. So we need to put pick1.tag, this picture box here called pick one, we need to tag it as belonging to player one. Okay, so it's player one's turn, they clicked in that box, we put their red X image in there, and this is how it would work if you were doing Passy and the Koala, because your picture in here would be of Passy, and so you'd have your pick one image equals the pick player one image, and it would pick up the image of Passy and put that in there instead, or of Batman, or the Coyote, or the Roadrunner, or whoever your person is, okay? So the code's all going to be the same no matter what version images you use on there. You just change your images here for the two different players. All right, else, we need an else. Otherwise, because it might not be player one's turn at the moment, that box could have been clicked on by player two. So we have an else here. So the other situation, well, it must be player two if it's not player one, because we've only got two players. So that pick one image here, we need to put the pick player two, the round circle, into there. All right, and we need to tag that as belonging to player two. And then last of all, in each of these situations, we were just keeping track of the number of squares. So another square is being claimed. So you need to do number of squares equals your previous number of squares plus 1 to bump your number of squares up by 1 because another square has been claimed. So look, that's the code for claiming one picture box. And the thing is, that code's going to be exactly the same. The logic, the steps are exactly the same for every picture box, except we're just changing the number of the picture box. Okay, so that was the hard bit, getting it done for one picture box. So pause the video, get all that code in there for one picture box, and then what we'll do, of course, is we will test it. All right, so when you run the program, it's player one's turn here. And so when we click that picture box, you can see player one symbol, the red X, goes into that picture box. All right, so do that code and do this test and make sure it's working. All right, at the moment, we haven't put in the random numbers to pick a random player to go first. So player one's always going first. So this should come up player one, because that's what you typed when you designed the form. And so it should just be doing player one's image. We'll get on to fixing it up so that player two can sometimes randomly go first as well later on. That's another little step of our agile building. All right, so we need to add some code to that pick one event that we just set up to make it change player turns, because otherwise it's just going to stay with our form there, just doing pick player one all the time. So we need to actually add a little bit more code into what we just did there. So for the pick one tag, okay, equals nothing, so the square was blank. If we're doing player one, and we've just straight after where we did number of squares equals number of squares plus one, that's where we'd finished previously. Add in this other code, as long as the Boolean game over is false, so as long as we haven't finished the game yet, then you need to change the label turn text to say player two, all right? And we're also just doing a nice little thing here. We're going to change the color of the text to goldenrod, which matches the color we've used for player two, that golden kind of orangey color, all right? And else, on the else part, which is underneath here, okay, down where we had number of squares equal number of squares plus one, we just need to add these extra lines of code in here. If the Boolean game over is false, as long as the game is still going, set it now, swap it over to be player one's turn, and player one's red. So we just set the for color of that text to be red, okay? So we add the code shown here. It goes directly where we had that number of squares equal number of squares plus one. Make sure you do it in the section for player one and the section for player two, as we've done here, and then we can test that out. So player one, it was their turn. They clicked in that pick one. That's the only one we've got set up that they can click in at the moment. And the red square went in, and you'll notice it's changed over now to be player two's turn. Okay, and notice the for color of this is the same sort of color as down here, goldenrod. So that just kind of makes it in your brain easier to see that, oh, it's player two. Oh yeah, player two is the orange one because we've got the orange writing up here. Okay, so that's kind of just good design to help people out. And that all happened because we had, if the Boolean game over is false, set the label turn text to player two, and we've made the for color of it this nice goldenrod kind of orangey color. Okay, so it logically matches up. Yes, it is definitely player two's turn, so when they click, there's going to be an O go in there once we've got those clickable squares set up. Now to get the rest of the clickable squares set up, because that's all the code you need for whenever anyone clicks on any of the 9 squares, the easiest way to make the rest of the picture boxes, pick 2, pick 3, pick 4, up to pick 9, is actually by using Microsoft Word. Now there is a replace all in VBNet, but we find it better to put it in Word because we can just take an isolated section of code, and we know we're only doing the replace all in that. Whereas if you do the replace all within the VBNet editor, it might replace it in other sections of the code where you didn't want to do it. So we always take the code we want to work on. So what we're doing is this private sub we've got for pick 1, you need to carefully drag your mouse, and you can't see it here, but we took it right down the bottom. So we had all of that private sub pick 1 all the way down to end sub, all that code we've just developed. Okay, we're going to highlight it all, and then we're going to use the keyboard control, hold down control with your left finger and click and hit C on your keyboard to copy it, control and C to get a copy of it. And then we take it into a blank Microsoft Word document, and we use Control V to paste it into here. So this is Control C, Control V, copying and pasting. And if you don't know how to do that, just Google it, Microsoft Word, Control C, Control V, copy paste, or look it up in YouTube. I'm sure someone will have made a video on it, but it's very straightforward. Highlight the code you want to grab a copy of, press Control and C, and then over in the other blank Word document we've got here, Control V it in, and we've now got the code here all in Microsoft Word. And what we do now is, in Microsoft Word where that code is, if you're on the, as long as you're on the Home tab, up the very right hand side of the screen there'll be this replace, and you need to click on replace, and that brings up this find replace text box here, and we want to find all the pick 1s and we want to replace them with pick 2s. So that's basically going to change our pick 1 picture box code into some handy pick 2 picture box code. So the pick 1 subroutine, we just need to change every pick 1 to be pick 2. Then we're going to have some code that can do picture box 2. Okay, so we're just using replace all, and you click replace all, and what should happen is it should tell you it's made 9 replacements as everything's going all right. So that's step 2 finished. Step 1 was to get it out of the VBNet editor, Control-C, Control-V, get it into a blank Word document. Step 2 is to use replace all in Microsoft Word in that document and change all the pick 1s into pick 2s. Just saves you typing time doing it. Then our final step is we can now copy this code into our program. So you highlight all that code that we just made and is now pick 2 code, not pick 1 code. So highlight all that with your mouse, click Control-C to copy it, and then underneath where we had all that pick 1 code, just press enter a couple of times to make some space, and you're going to Control-V it in here into your VBNet program underneath the pick 1 code. So there's all our pick 1 code, and here's all our pick 2 code, and this should work. So we should now be able to click pick 1 and pick 2 because we've written code for both of those picture boxes. So let's try that out. What's happened here on the screen we've got is that player 1 went first and clicked in the X in this top pick 1 box, and then it was player 2's turn, so they clicked in here and claimed pick box 2, and now it's gone back to player 1's turn. But of course, if you click in any of these, nothing will happen yet because we haven't written the code for those boxes, but we're going to be able to do it very easily by just replacing in our Word document that we've got there and then copying that in underneath, keep going under in our VBNet program. So that's what we'll talk about now. So the doc currently has all the pick 2 coding in it. So we need to use replace all and change all the pick 2 to pick 3. Okay, just exactly the way we showed you. And that'll be the pick 3 code, and you can copy and paste that into your Visual Basic editor. Then to do all the rest, it'll be sitting on pick 3 code. So you just do a replace all and change all those pick 3s to pick 4s. Take all that stuff and copy it into your VB code. It'll be sitting on pick 4, so you do replace all, pick 4's changing now to pick 5, grab all that word code, put it into the VBNet program, and so on until you will have just done pick 8. And then if you replace all pick 8, changing it into pick 9, it'll do it all in Word. All the word code will have pick 9, pick 9, pick 9, pick 9. You can highlight all that word code, Control-C it, and then Control-V it underneath where you've been doing all the other code in your VBNet editor. And then you should be able to claim every square which is on there, and it should also alternate players while you're doing that. So test the program, and you should now be able to, we were just going left, right, I think here. You should be able to just fill in all those boxes, and it should swap between players. So notice player 1 was going first, so they've got an extra square. That's why they get the advantage of going first. And then straight away after them, player 2's gone, so they've claimed 4 squares. And we actually have a winner there by the looks of it. Someone got, the player 1 got, they've won twice. Okay, that's interesting. So this is why we need this program checking code that we're going to do next, because otherwise people can just keep going until all 9 squares are filled. And yeah, player 1 can win twice. Never heard of that happening in Tic-Tac-Toe or Naughts and Crosses before. All right, so that's going to be our next step. So you could finish the program here and just play it like the pen and paper code that someone will see, like when they won the first time, maybe it was this down diagonal here. They go, right, yay, I'm the winner. Yeah, okay, let's stop the program. Well, let's just stop playing now because we finished that game, and not keep clicking on and win twice. All right, so that's our next job. So look, you could finish it there, and what you've done is you've made a copy of, you've just made a computerized version of the pen and paper process. But we're going to do more than that. We're going to learn about coding, about the power of the computer, about tagging things in VBNet, and we're going to make the computer work out when someone has won and stop the game so it can't keep going like it has in this situation. So this is going to be part 2 of the project. So look, this has been a bit of work getting here because we've already done, oh my goodness, 34 minutes on the video. So it's going to be a long one. It's kind of 2 lessons. Oh, it's kind of like 3 lessons in one, really. Okay, so just call this lesson 1. That was making the grid and sort of making a computerized version of pen and paper. So if you want to just stop here and come back another time, totally, and do the next part, checking for winners, that's fine, because remember, we've got that timeline index in the description for the video, so you can just go to that and come into the timeline index, find part 2 tomorrow or another time, and finish this off, because that's been a bit of work making part 1. All right, so take a break if you need to. Maybe it's going to be a whole day break. Maybe you won't be back for 2 days to do part 2. Doesn't matter. And let's get into part 2. Oh, welcome back. Okay, so now we're doing part 2. So next part, oh yeah, we have to do that randomly selecting who goes first, because whoever goes first gets a big advantage by going in the middle, because there's more combinations for them to win. And they're also going to get an extra turn. They could get 5 turns and the other person only gets 4 when all 9 fill up. So player 1 going first is a big advantage. So we want to randomly pick who goes first. Otherwise, the person who goes first, player 1, it's more likely they're going to win all the time. All right, so in that form 1 load subroutine that we already have, we're going to add some extra code in the bottom of it. So here's where we were just setting the winner stuff invisible. So underneath that, what we're going to do is we're going to generate random numbers. Now, if you don't understand this at all, you need to go back to the rolling dice lesson that we did in this game sequence, and that explained all about random numbers and how they work. But we're basically just picking a number between 1 and 2, and if the number comes up as 1, well, player 1 gets to go first. And we set up in that box to say it is player 1 and put it in player 1's color, which is red. But otherwise, it could have maybe come up as a 2 as a random number. And so player 2 is going to get first. So this should kind of, over time, long-term probability, it should be a 50-50 split as to go who goes first. So in multiple games, as we're going to build in the challenge tasks later on, you know, there won't be an unfair advantage because one player's getting to go first all the time. So that's the first thing. And just as we're always doing with Agile, we're putting that code in and we've built it. So now we need to test it. So before we go on with any more code, we just test the little thing we've done now is working. And that's how you break down a big 500 or 700 line program into manageable steps that you can build and test, all right? The same way as a car going along the assembly line, you know, they put the engine in and the gears and the diff or whatever, they might rotate it just to check the wheels are turning around while the diff turns around before they go on and add interior and seats and navigation systems and all that stuff. So they test along the way as they go, and that's what we're doing. So what should happen is if we run this a few times, we've ran it here and it's come up that player 1's getting to go first. Run it again. Player 2 got picked this time. So you got to make sure sometimes it's player 1, sometimes it's player 2. Also just check that the filling in the squares works. So player 1 got to go first and grab that middle square because that's a smart thing to do when you go first, and it has changed over to player 2. So check that the turn swapping or alternating is still working okay. So here you can see it must have picked player 2 to go first, and they've claimed that middle square because they're learning and they're smart as well. And now it's saying that it's player 1's turn to have a go. All right, so tests out a few different squares and we can see here what's happened. We've had a few goes. Player 2 must have gone first because they've got 3 squares here and it's now player 1's turn. Okay, so there we go. That's it. We've got it swapping between players initially at the start to pick who gets to go first, and then while gameplay happens it goes player 1, player 2, player 2, player 1, whatever, in the right order. So that's all working. So now checking for a winner, check for the end of games process. Remember there was 16 ways because each player has 8 possibilities to get 3 in a row, and there's 2 players, so 8 times 2 is 16. So they're all the checks that we need to do. And again, just like getting those picture boxes to click and get tagged and the player symbols go in, we're not going to do them all at once. We'll just do one of the combinations and then we'll work out some smart Microsoft Word copy and paste to make it easier to code all of the rest of them and put them in one by one and test them, all right? Because it's going to be a big job to try and get all 16 going at once, all right? We don't do it that way. We do it bit by bit, step by step, the agile process. And then don't forget the check for end of game Those are all 9 squares are filled too. We'll have to worry about that later on, but not yet. So we're going to put all of this processing in a new subroutine called check for end of game. And the first check we're going to do is that top row, okay? So pick 1, pick 2, pick 3. Maybe player 1 got all of those. And so we'll have if, this is pseudocode by the way, not VB netcode, but if pick 1 is tagged as belonging to player 1, and pick 2 is also tagged as belonging to player 1, and pick 3 is also claimed by player 1, we know player 1's got all 3 in a row up the top. So they've got a winning streak there, 3 in a row. So player 1 wins and the game's over. Else, if we're just checking those top ones, let's check, because maybe player 2 has claimed all 3 of those and has got those tagged, okay? So we check that out. And if that's the case, if they happen to have O's in all of those, and so their tags will be tag 2, showing they belong to player 2, well then player 2 wins and the game's over. So that's the first thing we're going to work out. We're just working these top across combinations just to see if anyone has managed to win getting the top across squares filled in. And so we need to convert that pseudocode we've made there into VB netcode, and we'll show you how that looks. So checking for end of game, we'll just put our little grid there to remind us how the picture boxes go. Pick 1, pick 2, pick 3. So we're just checking 1, 2, and 3 across the top as our first check here. So check if player 1 has those top 3 squares, 1, 2, and 3. So if pick 1 tag belongs to player 1, pick number 2 belongs to player 1, pick number 3 belongs to player 1 as well, then let's make the label visible winner, and let's put up there party time celebration GIF, and let's put also that the turn text now, we'll just put the word finished in there, and we'll set game over to true, okay, which is important. Later on we'll see why it's important that we set it to game over and make sure the game doesn't keep going. All right, that someone's won, so we need to stop the game, so Boolean game over equals true. So that's covered off if player 1 happens to have all 3, but maybe that isn't the case. Maybe player 1 has been working on 4, 5, 6, 7, 8, or 9 or something. It doesn't have any symbols in there. So let's just check, maybe player 2's managed to get 3 symbols across in that top row. So if pick 1, pick 2, and pick 3 all belong to player 2, then yay, player 2's won, and we need to say that game's over and set up a finish message on our screen. So note that as soon as player 1, we're displaying it on the screen, and we've also got this exit sub. So what exit sub does is, as soon as you find a winner, because we're going to have lots of checks here, we've just done 2 of them. Remember, there's 16, so we've got 14 more of these to do. But we're going to have lots of them. Now, if somebody's already won, it's pointless to go down and keep doing more checking to see if there's any other winners, because someone wins this game before the other person, and that's it. There's only one way of winning. So once you find that someone's won, we need to do this exit sub, which will jump out of this subroutine so that we don't bother going all the way down and checking all 14 other combinations or whatever it is, okay? So that's the use of the exit sub. Some purist programmers will say you should never use exit sub. Here at Passy's World of ICT, we say let's use exit sub instead of writing giant if-else statements that are hard to get right and hard to test, okay? So we cannot test for the check end of game subroutine yet though, even though we've done that coding to see if somebody's won, because that's just in a subroutine, and we actually haven't made any call in the program for it to go off and do that subroutine. So if you run your program now, the code's sitting there, but it'll never get done. It's sort of there ready to go, but we don't have anywhere in the program that says, hey, go and do that little subroutine. So that's what we need to add in next. So we need to check for end of game. Every time that a player's claimed a square, maybe they've got enough squares now to win. So back in our pick 1 click, pick 2 click, where we were tagging the squares and getting the players' images in, we need to go back and add more code, and we're going to add it is straight after number of squares equals number of squares plus 1. So everywhere in our program where we've got number of squares equals number of squares plus 1, we need to add a check for end of game with the brackets, and that'll make it go down and do this new subroutine we're building that will check whether it's the end of the game. Now, if you didn't do that way, oh my goodness, you would have to put all 16 checks in this spot just here, which would be insane because you'd be copying all of those steps for every one of these picture taggings, and your program would be enormous. And if something was wrong, you'd have to go and fix it up in 16 different places, okay? think about it, just be crazy. So this needs to be a separate subroutine, checking for the end of game, and we need to make sure we put it in every time we got a number of squares equals number of squares plus 1. Just add in that check for end of game, okay? And if you do that properly, there should be 17 places altogether that have number of squares equals number of squares plus 1, where you need to check for end of game. And 17, I'm just thinking about the math for that, 17 other places. We've got picture box tags, and we've got 9 picture boxes, and 9 times 2 different players is 18. We've just done 1. So yes, there are 17 to go. So that is the correct number. But look, it's easy. Just go to where you've got your first pick one click for doing squares. You'll find your number of squares plus 1. Have this control C, so you can just control V it in. Go further down, there'll be another number of squares plus 1. Make a space, control V it in. Go down, there's another one, control V it in until you've done all 18. So we did this one, there's 17 more to go. I hope that all makes sense. If it doesn't make sense, and if you get totally lost and your program's not working at all, make sure you get the downloads for this lesson, because we've got a full listing of the program, so you can go through and compare yours line by line and find out where your problem is, because all you need to do is get 1 or 2 lines wrong in a program. Unfortunately, it's a bit like a house of cards. It all kind of tumbles down. It's not going to work properly, so you may need to get the downloads for this lesson. You should always get the downloads for the lesson, actually. It's going to make it so much easier than just watching the video, although the video is a good thing. Okay, so we can now finally test, now that we're actually getting it to check for end of game, whether this top row is working, because remember, we've only coded so far for people winning across the top row. We haven't done the other ones yet. So if player 1 goes and we just play silly and let them get all 3 of those, notice it says the game's finished and we've got the celebration message happening for player 1 and they're the winner. All right. And also, if player 2 happened to go and we just let them win, let them do 1, 2, 3 across the top while we're silly and just mess around doing other squares, we've got the detection in there for that top row, and this time it's detected player 2, says it's finished in player 2's colors, which is useful as well, and we get the winner message there, yeah, for player 2. I think I'm not sure who that is. It must have been someone on The Voice, that TV show. Anyway, it's a cool animated GIF we found on the internet. And since it's just for educational purposes and we're not selling it or anything like that, this isn't a copyright violation in Australia. All right, winning on the top row across. So that's working for both players. It's working beautifully. So we need to get the middle row. Can someone get all 3 in the middle, or all bottom ones across here in the very lowest row down the bottom? And then we need to do our verticals and our diagonals. So I've got all these other combinations to do. But hooray for Microsoft Word, because what we can do is, we've got code that does pick 1, pick 2, pick 3 for the top row. For the middle row, we just need to change all our pick 1s to be a pick 4, all our pick 2s to be a pick 5, and all our pick 3s to be a pick 6. All right, so the replace thing is going to be really cool. So get all of this code, which is checking for the top 3 squares, and just Control C, highlight that with your mouse and Control C, and put it into Word, and then all you have to do is do replace all, and first do pick 1 and make sure that gets replaced to a 4. Then work on replace all again and replace pick 2, changing over to be pick 5. And then one more replace all in Word. Pick 3 changes over to be pick 6. Or, wherever you've got 1, 2, 3 in here, you could manually type 4, 5, and 6 if you wanted to, if you didn't want to do the replace all. Either way, you just need 1, 2, 3, 1, 2, 3 to change to 4, 5, 6, 4, 5, 6, and we'll be doing the middle row instead of the top row. So you get that done, and then of course you have to carefully Control C that from Word and Control V it into your program where you're up to in that check for end of game routine. Put this one straight under where we did pick 1, 2, 3 stuff previously, and then we need to do 4, 5, 6 and all of the others. And let's just stop though, agile development, and check where that middle row one's working. So again, if we play silly and let player 1 grab all the middle ones, it does get announced that player 1's the winner, so that checking's working, and it's also working for player 2 if they grab all of the middle ones, all right? So we need to keep copying and pasting from Microsoft Word to get all of those different combinations for going across and also going down the left-hand side, going down on the middle and going vertically down on the right-hand side, plus your two diagonals. And once you've got all that code set up and copy and pasted and winning, you need to, then thoroughly test the thing. So let's just show you. Here's your player one code, pick 1, 2, 3 stuff. And when we're doing that bottom row, we need it to change to 7, 8, and 9. So grab all this code here out of your VBNet program for the top 3 squares. Just grab it, paste it into Word. Do replace all in Word. 4 has to go to 7, 5 has to go to, 1 has to go to 7, 2 has to get changed to an 8, and 3 has to get changed to a 9. Okay, then you can take all this code here and your 1, 2, 3s need to get changed to 1, 4, and 7. So 1 could stay as it is, but you need to change 2 to 4 and 3 to 7. And then to set up this next one going down in the middle, you'd have to take your 1, 2, and 3 from this code and change it to 2, 5, and 8. Okay, so we're just making all these different sections of code until we have all of these combinations. So to get this last one, this diagonal that starts the top right hand corner and goes to bottom left hand corner, see that's 3, 5, 7. You'd have to change 1 into 3, 2 into 5, and 3 into 7, and then paste that code in underneath, and then you would have all of your possible ways of winning covered. All right, so we can get all that working and get winners and set Boolean game over to true. But remember, there is that possibility no one wins and we get all 9 squares filled up. So at the very end of this check for end of game subroutine, we now need to add in one more thing, which is checking for the draw. So this was that diagonal one we were just talking about, the 5 and 7 and 3, 3, 5, 7. Now, just where you did that last lot of code, right at the very bottom of that check for end of game subroutine, just before the end sub, you need to have, if the number of squares now has actually reached 9, we did all this checking, we don't have any winners, but all 9 squares are filled in. Game over message because it's a draw, all right? So you need to put that in, and that will be one of our tests as well. Okay, so when we play some games to get a draw, and here's one here where all the squares got filled up, but nobody got 3 in a row to win. And you can see the message box is coming up correctly. Game over, no winner. And you click OK and the message box disappears. All right. So that's all working fine. So final program testing, you need to play a lot of games to make sure things are working. So this diagonal winning for player 1 was working and they won the game okay. Here we had player 2 win straight down the middle. And you can see that's the computer checking has detected that and showed the winner message. Here we've got one where player 1 won across the bottom. So don't play serious games, just fill in squares and make sure these combinations are working. And here we've got player 2 winning with the right hand downs. So that's all working. We've got the middle one here being won by player 1. And we've got the left hand downs being won by player 1. Now there's a whole lot more you need to test. So you just need to run all these things and see that, 3 in a row for player 1 and for player 2, that they're all working okay and the game is good. And then you'll know we're actually finished. So we've made our noughts and crosses game and we've got the computer to check. That's all looking pretty good. Except for one little thing, a however, and there's always a however. If you do some rigorous and thorough testing, you'll notice that you can play on after a win. So what's happened in this game is that player 2 has won the game by getting 3 down here, and so it says the game is finished, but you can still click in here of your mouse. And if you do click in there of your mouse on these 3 empty squares in the corner, because it stayed locked on player 2's turn, because we had that, end of game false. So it's only going to swap the players if the game hadn't ended. So when the game has ended and there's been a celebration message, player 1 can never go again because they were the loser, but player 2 can actually keep going. And look, they've won again across the top. So we want to stop that. We want to have it so that these squares here, once someone's won, any empty squares, we need to have the program find the empty squares and to disable them so that people can't click on them. All right, now how do we find an empty square? An empty square will be one where the tag equals those quotes, that the tag is nothing, that no one's claimed it and tagged it. So we can check all 9 squares and find the ones that are not tagged, and then all we need to do is disable the picture box so that you can't click on it. All right, now do you really need that? Would people be silly, like player 2 is quite happy that they've won here with the 3 down. Would they really want to play on and try and click the rest? Look, maybe not. So maybe you could say, nah, this is silly, I'm not going to do this, and my game is finished here because I've spent a long time making it and I'm really tired and I need a rest now. Look, that'd be okay, but look, in the challenge task, we want you to challenge you and want you to fix that problem. So that's going to be one of the challenges. So let's get into them. I think it's going to be challenge 2 though. Challenge 1 is a reset button, because once you played once, especially if you didn't win that one, you're going to just go, I want a rematch, I want to play again. So we need a reset button. So down here, we need to have a button called reset so that people can click that button. And what will happen is that the whole grid clears off. We get rid of any winner messages that are hanging around, and we're ready to play another game. And it's randomly chosen that player 1 gets to go first in this game. Okay. So we need to kind of redo all that stuff we did at the start to set up the blank playing grid and randomly pick a player to go first. So things you'll need to code in to de-tag these picture boxes which have been claimed. You'll have to check all 9 picture boxes, or go around for each of the picture boxes, and you will have to set pick one tag back to equals quote quote, so it's got nothing in it. And if you want to clear the picture box, get the image out of there so it goes to a blank picture box, you need to say pick one dot image equals nothing. Okay, so you'll have to have all this code. You'll have, when they double click on the reset button, it'll make some event code for when the reset button's clicked. In that event code, you need to have like pick 1 tag equals quotes, pick 2 tag equals quotes, pick 3 tag equals quotes, all right? For all 9 of them, to make sure that they're untagged. And you'll also have to have pick 1 dot image equals nothing, pick 2 dot image equals nothing, so that they all end up clear empty boxes like this. And then you'll have to just copy and paste the code you had out of the initialize section to randomly pick who goes first. And also reset your counters. Make sure you reset your number of squares back to 0, because if you don't, you won't be able to play because it thinks all 9 squares are filled or something like that. Or what will happen is you'll start playing, and after 3 squares it won't let you do any more. So weird things will happen if you don't reset your number of squares to 0 and reset that Boolean game over is false, I think. So check whatever you did in the initialize, and you need to do that for this reset event as well. And then that should all work. You should be able to play multiple games and that'll be lots of fun. Now challenge task 2 is to fix that problem of playing on. So we don't want them to be able to play on when there's empty squares and we've already had a winner. So here's some code to get you started. You'll need a new subroutine, disable empty picture boxes. So as soon as someone's won a game, after that point in the code where you put messages up for winners, you also need to put up disable empty picture boxes. So it'll go down and do this subroutine. And you just got to go around to all those picture boxes. So just check, pick 1 tag. If it's quotes, you know it's a blank one. So pick 1 dot enabled equals false, and that means they can't click on it. And just, you know, if pick 2 dot tag equals spaces, pick 2 dot enabled equals false. If pick 3 dot tag equals spaces, pick 3 dot enabled equals false. So you'll have to put a whole bunch of code in there, and that should then disable any ones which are empty. And you'll find that when you run it, you can't click on those, okay, after a game has finished. So that should be easily fixed, and we should challenge ourselves and do that. So it'll need to have 16 spots in the program where you tell it to do disable empty picture boxes, and then it'll come down and do this code to make sure any blank ones are disabled and no one can click on them. Now that's also going to mess up your challenge 1 reset button, because you will have disabled some picture boxes by this process. And so what you need to do in that reset button is also have some code that'll just set every picture box, all 9 picture boxes, dot enabled equals true, just to make sure that they're all enabled at the moment and ready to go when you do a reset, because it might have been a end of game with empty boxes, probably will have been, and some of the boxes are disabled. So if you forget to do that, you'll find you do a reset and then there's certain boxes you can't click on. You'll be wondering, what was going wrong? I could click on these boxes last game. It'll be because you reset. So yeah, programs can get complicated, and changing one part can have effects in another part that you didn't think about. So it's always important when you do this agile development and you add one more thing or change one more thing, that you redo all of your testing to make sure nothing else got broken. And yeah, look, this is painful, it's a lot of work, but that's part of what being an application developer or a games programmer is. And being a games programmer is being challenged, so you want to do challenge task 3 as well. And for the third and final challenge, just stretch it to make it a bit bigger. And we want to keep track when we're doing reset and playing these multiple games, what's the total of wins for each player so far. Okay, so at the moment, player 2 has won 5 games, and we just finished, and player 1 has got their 4th game by the look at it, because they're up to 4 wins, all right? So that shouldn't be too hard to add in. So you need some program variables that count wins for player 1, program variable to count wins for player 2, and every time they have a win, you need to add 1 to that variable. And you also need a couple of boxes, labels to display it onto the screen. All right, so that's it for this lesson. It's been a really long lesson, so we hope you paused it and did it in sections. We've been going for just over an hour on this, but remember there's the next lesson and all of our lessons are on our website in the VB Games section, and that's where you go to also to get the links for where the download items are. So check that out, VB Games, on the PassyWorldOfICT.com website, because YouTube is just where you put the videos, but the actual courses, and more importantly, the order you need to do the lessons in for the learning, because every lesson we do builds on things you've learned previously, so it's important you do them in the correct order. If you don't know what the correct order is, go back to VB Games and tick off as you go down the list the ones you've done, and you'll know what you're doing. So have lots of fun programming with VBNet, and that's the end of this lesson. Look, there might not be another lesson for a little while, because I had a whole bunch of requests to do, believe it or not, of all things, Python programming. And as you know, Passy, that's why I wear the purple shirt, we love VBNet. It's such a superior high school education, or a beginners at any level, you don't have to be doing high school, to learn programming, because you got the form and you got the screen, you can do fun things on the screen. Python, you don't have screens, and it's really hard to make screens and is long and takes a lot of work. So we don't recommend using Python at all. But look, we got a lot of requests to do a Python course, and as it turns out, in my day job, I'm going to be doing someone else's Python course, and yeah, I reckon it could do with some improvements. So we're going to write our own kind of Python course as well for the world of ICT, and then this class can use some of the bits and pieces from it. So there'll probably be a Python course, beginner's course, coming up, and we'll kind of try and alternate so that we do like a Python lesson, then we do another VBNet Games lesson, then we do a Python lesson, then another VBNet Games lesson. So yeah, we'll see how we go with all of that. But anyway, like this video, give it a thumbs up, subscribe to our channel, because we've finally got over 1,000 subs, which is fantastic. But YouTube says we don't have enough views yet. So tell your friends about the channel, because it'll help them with their learning as well. And we'll see you in the next lesson. Could be Python, could be VBNet, but we'll see you.